Here's another example of fitting different sized cubes into your volume, into the rectangular prism. And this time I'm going to use 1/4 by 1/4 by 1/4 inch cubes instead of the half that I did in the last problem. So same type of problem. If I were to fit 1-inch cubes across, I could fit 3 2/5 of them in here, but I'm not. I'm making them smaller. I'm cutting them into fourths, so I can really fit 4 times as many in the length, 4 times as many in the width, and 4 times as many in the height. So instead of that half where I could fit twice as many, now if I'm splitting them into quarters, into fourths, I can fit 4 times as many cubes in all 3 dimensions. So I'm going to solve it 2 different ways. Here, we'll do way 1 over here, and then I'll do another way over here, way number 2. The first way I'm going to do it is I'm going to multiply each dimension, length, width, and height, by 4. And then I'm just going to solve for the volume that way, length, width, height. Okay, this is the same rectangular prism that we used in the last example as well. So I changed them all into decimals. And I'm going to do that again. So this would be 3 4/10. And I'm going to multiply it by 4. Which in my calculator gave me 13 6/10. Okay. Then I'm going to take my 5.5, 5.5 as a decimal, times 4 in my calculator, which gave me 22. And then I'm going to take my height, 2 3/4 is 75 hundredths. And if I don't know, I can just do my 3 divided by 4 in my calculator. And I'm going to multiply that by 4 in my calculator. And that gave me 11. Oops, 11. So now that I have these new dimensions, my new length, my width, and my height, now I'm just going to solve for the volume using those. So length times width times height, 13.6, so 13 6/10, times 22 times 11, I'm going to plug that in. And in the end, I should have 3,291 2/10. That's how many 1/4 by 1/4 by 1/4 inch cubes would fit in. So that first way, I multiplied each dimension, length, width, and height, times 4, because I can fit 4 times as many cubes. And then I found the volume using those numbers. Okay. The second way that I can do it is I can first just find the volume of 1 inch by 1 inch by 1 inch cubes, which we did in the last problem. So that would have been, 3 4/10. I'm just changing these dimensions into decimals, 3 4/10. This is 5.5, 5.5, times my last height was 2 75 hundredths. Okay, when I multiplied all those together, that was when I had that 51 425 thousandths. Okay, that's that 1 inch by 1 inch by 1 inch cube. But now I have a new dimension. Right, I'm looking at, let me see if I can change my color here. A times 4, a times 4, and a times 4. That's 4 to the third power. And 4 to the third power is 4 times 4 times 4, which is 64. So now I'm taking my volume and I'm multiplying it by 64, which ends up giving us that same answer, 3,291 2/10. So you have 2 different ways that you could solve it. Don't combine them, they're different. So you can either pick way 1, where you're multiplying each dimension by 4 and then finding the volume, or way 2, where you're finding the volume first and then you're multiplying it by, in this case, it'd be 64, because that's 4 to the third power.